All right, so in our next session, we're going to start to get our hands dirty with some data. We're going to be working with tabular data, and we've got Thomas Martin from Unidata who's going to give us a tutorial on exploratory data analysis using tabular data. Welcome, Thomas.
Awesome, thanks so much. I'm going to do some quick housekeeping since I'm the first Jupyter Hub talk of the day. One thing, if things aren't inputting correctly, or you're like, why isn't, import pandas as PD? Why does that not work? One thing to look at in this upper right-hand corner is your environment. And there's a couple different options. There's root, IPY kernel. The one that we have handcrafted through a lot of time of Unidata staff is Users Workshop 2023. So if you're having any problems or issues using the Jupyter Hub, that is one place to start. We've had some updates to our materials, and so in the file structure, there should be a notebook that says update workshop material.ipynib, and it is only one cell. If you've never used a Jupyter notebook before, it's Shift-Enter to run the cell. You should see a star. It's going to do a little git fetch. And this is how you're going to make sure you have the latest and greatest material in your Jupyter Hub. If this doesn't work for you, your computer's on fire, and everything's breaking, I did put in the Zoom chat, there is a link to the notebook I am going to be using that is on GitHub that has all the output saved. So I would highly recommend following along there, and then reach out to me, catch up, and we can work one-on-one after this talk to make your computer less on fire. Okay, so with that, I'm going to be doing a super quick, kind of a Python tutorial. I'm sure many of you in this room, probably use Python every day. Some of you, this might be day number 1. So this is just going to be a super quick introduction to Python. There are many tutorials online. I'd be happy to point you to some. Unidata, we also put on multi-day workshops that also run through Python and Pandas much more in depth. So Drew led to this in the last talk. So when to use Pandas. So Pandas is a tool for tabular data or point data, commonly stored as CSVs or Excel files, or even Apache Parquet files. If you have gridded data sets, X, Y, Z, T, these are commonly found as NetCDF or GRIB. Xarray is probably the preferred tool for that sort of data analysis. And if you're like, I don't care about point data, my whole life is on a grid, then just hang out for 30 minutes, and John T, that is the next talk going over Xarray. So if you have very large data sets, if you are a big data enthusiast, Pandas is an awesome tool. I would say starts to run out of steam 3, 4, 5, 6, 7, maybe 10 gigabyte data sets. It all puts it into memory. If you're like, I have half a terabyte worth of unstructured text data I want to do analysis on, there are other tools that might be a better fit than Pandas. That would be a serious laptop on fire situation. So there's Modin, Dask, and Polars. They all have their pros and cons. Some work on GPUs, some don't. Some use a strict Pandas API, some don't. And so if you have questions about those tools, or like, oh, I have 30 gigs of data, what should I do next? Feel free to shoot me an email. Okay, we're going to do a couple of imports. If you've never used Python, you have to import packages. One reason why Python is so powerful, that has all these little toolboxes or tool sets, if you're using sort of the MATLAB nomenclature, that you can import in, and it can do a lot of the hard work for you. So we are basically the one at the top, import pandas as PD. Why we're importing it as PD is because we, as programmers, are lazy. Pandas is long, PD is short. And so the less characters I need to type, the better. Less room for error that way. So import numpy as np is sort of the same thing. These are very common as imports. One way to make Python people's brains break is like if you did import pandas as like PAN or something. Like, no, just please use PD. That's what 98% of the users use. Okay, next we are going to get a file name or a data set. This, I'm actually pulling it directly from a URL. One nice thing about Pandas is that you can use URLs directly. And before I get too ahead of myself, just to double check, if this is your first time interacting with a Jupyter Notebook or a Jupyter Hub, it's Shift and Enter to run each cell. So on this cell, you see this number 25. If I do Shift Enter, it's 27. So you'll see the counter go up by 1 or 2, or it should go up by 1, but I ran this one right after that one. That's why I kind of got out of order. One downside to Jupyter Notebooks is that it can get, you can get lost in the sauce if you're running cells out of order, doing things all crazy. So it is best practice if you've worked through it's 2 a.m. the 2 days before your talk to do kernel restart and run all cells. Make sure that your notebook can run in order top to bottom without a choose your own adventure treasure map to sort of make that happen. But we have all been there. It's not super fun to debug. Okay, so then this next cell is pd.readcsv, and I'm pulling the file name, which is just the URL. I have a little print statement where I have df.shape, so we're going to save that in a data frame. So data frames can be named not just df. In almost every tutorial, they are called df, but if you call it df2 or df atmosphere data or df mywholelife.phd, that also could work. So, it's not just df. So for the shape of this is, 5,000 rows and 53 columns, which this isn't the world's largest data set. Many of you could do analysis of this data set in Excel. Excel is a valid tool. It's a useful tool. It will live forever. It will all outlive us as far as a scientific computing tool. One thing to sort of keep in mind is as your data sets scale even to 100,000 rows, which would be small for Pandas, that could be very large for Excel, or if you have 1,000 columns. And so while this data set could scale to Excel, if you had 10x in either direction or even both, that would be easy for Pandas to use, where the wheels might be falling off the bus for Excel. This, I just wanted to hit home, 5,000 rows, 53 columns, not super big, but the size of this data frame in gigabytes is almost a rounding error. So again, to move to these sort of tools that are bigger than Pandas, is truly big data. Okay, groovy. So now we have loaded data in, and there's different readers. We use the pd.read CSV. There's read Excel. You can read in CSVs directly. You can use different parsers. There's a lot of great information in other tutorials and also the documentation. And so if you have a question at the break and you're like, oh, my data set is in an actual Excel file or in a Parquet file, please come and grab me, and I would love to help you work through some of that. Now, we have 53 columns. If you just want a list of all the columns, you can do the df.columns, and that will give you a list of every column name. Luckily for this data set, came with the academic paper. They all have a label, whether they make sense to you or not. Probably makes more sense if you read through the paper. But if you have a data set that doesn't have column names, you can set that on read-in. And so even if your data set doesn't have the best metadata, you can update this data frame with that sort of data, with that metadata. With these 53 columns, we have a whole mix. of, if we scroll up, we have an ID, some lats, some longs, also some regions, some climatic zones. And so we can look at the different D types. So one thing that a D type is a data type. And so even though this is all a CSV, some of them are floats, which are floating, which are normal decimal numbers. Objects are generally text. int64 are integers. And so if you're trying to do math on an object, it can be sort of tough because Pandas thinks it's text. And so if you do 2 plus dog, Pandas doesn't know how to interpret that. And so some of your math errors might stem from some of these D-type issues, especially if you're debugging a data set and you have numbers in a column, but then you have bad data or sensor error or some sort of text parsing string as sort of your null flag. This is where you might need to dig into it, do some replacing, and clean your data a little bit more. Since we have a lot of columns and we're not going to use them all, especially for today's quick intro, you can use the df.drop. And then this, I just put in a couple different columns here. Again, you don't need to do this, and I set the axis to 1, which is making sure it's the columns. You don't need to do this. You can if you just prefer to work with smaller data frames, but any of the tools, especially if it's a smaller data set, not strictly necessary. Now, to piggyback off of Drew's talk, df.describe is a great way to sort of get a hot take of your numerical data in your data frame. You can get the count, the mean, the standard deviation, the min, the max, and some percentiles here. Now, one thing that is sort of that my eye is drawn to is that the count is the same for all of these columns. And so do we think that this data set is completely filled out? Or do we have some sneaky null flags in there, potentially like a -999? Okay, so now we look at some of these minimums, and we see a -999.00. So while these are real numbers and the count is true that this data point exists, probably for our analysis or your analysis, you don't want to use -999. So we will explore that further in a second. If you want to explore or sort of subset your data set more, like if you have a super big data set, you can use loc, iloc, and group by. So running this cell, what I'm basically saying here, I'm going to unpack this, and it's from the inside out. So in this data frame named df, where the climactic zone column equals cool dry, which is one of the options within climactic zone, locate all of the rows within that data frame. And so if you look at the output here, it only has that cool dry climactic zone, but it has all of the different IDs and countries and all of that. And so if you only care about one country, if you only care about one climactic zone, or a specific lat and long bracketing, this is one way you can subset your data frame. With iloc, you use the same, you use the index. So I'm only pulling rows 0 through 4 using iloc. I really don't use iloc that often because data sets change, data sets update, and I don't really want to keep track of on a post-it note on my monitor, oh, it's these rows that has the data I care about. It's much better to filter using other methods. But also using iloc, if you're just doing quick and fast, exploratory data analysis, you can use iloc for rows and columns, or if you have a particularly messy Excel sheet that probably some sensor outputs that part of your processing workflow where the indexes don't change, iloc can be useful then. If you're a SQL user, I saw one in the Zoom chat earlier today, group by might feel familiar to you, especially if you're trying to get some quick insights. And so this, what I'm saying here, for the data frame, we're going to group by, and then we're going to use the climactic zone as what we're going to group by, and we're going to pull the median for each climactic zone. So for instance, for the boreal dry, we have the median ID, which is like, that is a useless metric. Like, we never need the median of these integers, but maybe the median long, the median lat, probably some of these other metrics would be helpful for you as a median. You can use the mean, you can do a lot of things. Group by is very powerful. If you have a bunch of different variables and you want to sort of look at them at once using a single metric. You can do the same thing with country and type of area. Then you end up with a Pandas multi-index. And so for some of these countries, there's only one type of area. But for the United States, there's a couple for this. And so if you needed to figure out the median lat and long for remote versus rural versus suburban versus urban, you could do that very fast, all within one line of code within Pandas. Okay, NaN hunting. So this was kind of covered a little bit earlier with Drew's talk. So I'm doing, this is not a Matplotlib talk, but we're going to do a tiny bit of it. So PLT, so we're going to plot a histogram of data frame and then this one column of the ozone measured, of the median ozone measured. And so we have a lot centered around 0, and then this other sort of bar towards -999. So we know that this -999 is probably not a real data point. I'm sure if we read through the paper, we would find that in the metadata, or we would hope we would find that in the metadata. It says, from doing .describe in the plot above, let's get rid of all rows where, there's a -999. And so that is what I'm doing here. So I'm going to unpack this from the inside out. So in this data frame, looking at the O3 median column does not equal, and that's what the exclamation equal sign is, -999, so basically the NaN flag that was there. We're going to make a new data frame where everything where the O3 median does not equal -999. Then with this new data frame, we can do the same comment of plt.hist data frame dot O3 median. Again, you get something that you would hope to see. Again, you can do some of these filtering or subsetting even within the same line if you just need to make a quick plot and you don't want to make a whole new data frame. So for this, I want to compare the ozone 3 median compared to rural and urban. I also use some other Matplotlib options and a legend, and you can get a plot like this. So you can say like, oh, the urban areas have a little bit less ozone than the rural ones do. Using Matplotlib scatterplot, you can put in df.lon, df.lat, and you can color by the median ozone to get like this wildly, almost not helpful scatter plot. This is definitely a exploratory data analysis plot, not an explanatory data analysis plot. Just seeing, okay, I have a lot of stuff in the US, I have a lot of stuff in Western Europe, the global South, not so much. And so maybe not super helpful for some of those analysis. If you want to get some of those country codes, look at all the different countries that we have 65 of them. But if you rank the country codes by the value counts, we have a lot of data points in Japan, and we have one data point in Nepal. So, maybe this data set would be helpful if you're a Japanese scientist, and maybe significantly less helpful if you're a Nepalese scientist. So again, this is just one way to sort of explore these types of data sets. We can make a new data frame with just the USA data. We have 815 data points. Create another scatter plot. We have some nice Alaska data points and Hawaii and Puerto Rico. To cut this further down using Matplotlib options, you can set the ylim and the xlim, and you get this sort of squeezed out, not really, this is still exploratory data analysis for, some of these tools, but you can sort of see trends of where we have data points. You can fix this by using Cartopy, where you can overlay states or counties. Definitely fix the projection. This is not a projection. This is just, numbers picked for xlim and ylim. If you're interested in future work, there's a couple of tutorials here. There's a book called Effective Pandas by Matt Harrison. And so I know we were blowing through, and this is, people write 500-page how-to books for pandas. I'm not saying I was supposed to cover that here, but if you're working with tabular type of data sets that, is 10 columns or more, or 100 rows or more, I invite you to do that analysis outside of Excel and do it in Pandas. Or if you're in R, I know that the R data frame package is also quite nice to use as well, and you can do the exact same workflow I just did. This is not really language specific. These examples are, but what you can do outside of Excel is not. Just another quick thing, if you have any questions, comments about Python, please reach out to the Unidata Python team. We would love to help you out with your research project. And with that, that's it.
Thanks so much, Thomas. Maybe a time for a quick question or two?
So I work with people that are like heavy Excel users, like heavy.
Yeah, pivot tables, macros,
Yeah,
the whole VBA.
The
Yeah.
whole 9 yards.
Yep.
What kind of a lift would it be to convince them to move over to Pandas? Because this seems like that would help them tremendously. But I am the most experienced Python person in my group, and I started Pythoning very recently.
Yeah, well, congrats. No, I think the big kind of sales pitch is maintainability, especially, if you have linked sheets in a macro, like, oh, this is for Excel 97 to 2003. Oh, I have the wrong VBA. I'm not trying to say that Python versioning is like a walk in the park or like, one of its best use cases, but debugging some of those Excel macro pivot table link sheets, oh man, just life is too short. I would just rather do many other things. And so that would be one sales pitch. The other thing is the ease to make visualizations quick. And so to sort of, yeah, it's a data pipeline thing and a data viz, I think, because once you have one plot, it's easy to do that plot 1,000 times. And in Excel, you can do some of that, but it's still, I would say, not as intuitive to sort of do analysis at scale.
I actually want to add one other answer to that. If you're trying to make a sales pitch to take an Excel workflow and make it a Python workflow, use the Excel files that you're already working with or that your team is already working with. And you can even think of it as its own story. You're doing exploratory data analysis with these Excel data sets that you have, and you're showing your team how you can do that, what an Excel file looks like in Python, what you have access to in Python. And just by showing them something that they're already familiar with, even if it's just on one side of it, it makes understanding the new side of it that much easier.
Thank you.
Any questions from online before we transition? I don't think so. All right, let's thank Thomas one more time.